Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss cyclic structure of glucose, and also I will discuss a structure of fructose. Actually, carbohydrates includes glucose, fructose, maltose, sucrose, lactose. These are many are there, but these are common. Then you should know the structure of all these compounds or molecules. Then last class I have discussed a structure of glucose, but it was a open structure. Now I am going to discuss cyclic structure of glucose, or you can tell ring structure. Then here already I have discussed the open structure of glucose. Now I will continue, but you have to consider the previous structures what I have discussed for glucose. Open structure, it will help you to understand the cyclic structure. Last class I discussed three structure I discussed. In that first one was important. Okay, correct representation was first, means aldehyde group was attached at carbon number 2. Carbon number 2 means upside CHO was there, and carbon number 5th, from that CH2OH was attached. And in the middle 4 OH was there. Then out of that second carbon OH was at the right side, and third carbon OH was at left side, and next two were on the right side, means fourth and fifth OH was at the right side, and opposite side H was there. This is actually correct structure of glucose. And in CHO, that was also always obviously will write right side, and CH2OH, that is also right side, means right side out of 6 OH. Actually one is CHO, that you can't consider. Then 5 OH are there. Then out of 5 4 OH are at the right side. Only 1 OH, that is of carbon number 3, that OH is at the left side, only 1 OH, and other OH are at the right side. And where OH is there, opposite to that H is there. Now I will continue from this structure. This structure will help you to understand the cyclic structure of glucose. The structure 1 of glucose explained most of the properties, but some properties and facts could not be explained by this structure what I discussed now. Structure 1, what are that you can say fact which is not explained by structure 1? Then first properties or fact which can't be discussed by the first structure I am telling you. Then first point is that despite having the aldehyde group, glucose does not give 2,4-DNP test, dinitroproside test. Okay, despite first which can't be discussed, this fact that can't be explained by structure 1. That is the first you can say this properties which can't be discussed is Despite having the aldehyde group, glucose does not give 2,4-DNP test, escape test, and it does not form the hydrogen sulfide addition product with sodium hydrogen sulfide. Correct? This structure 1 fails. Structure 1 fails in these tests. Correct? Does not give a 2,4-DNP test, escape test, and it does not form the hydrogen sulfide addition product with sodium hydrogen sulfide. Here it fails. Next, in second, the pentaacetate of glucose does not react with hydroxylamine, indicating the absence of free CHO. Correct? This is very, very important point. The pentaacetate of glucose does not react with hydroxylamine. Then if it is not reacting, then what will you conclude? Indicating the absence of free CHO group, means CHO group is not free in glucose. Third point, third reaction, that is the properties which can't be explained by structure 1. That is the glucose is found to exist in two different crystalline forms, which are named as alpha and beta. Glucose, we know, glucose is found to exist in two different crystalline forms, which are named as alpha and beta. Always you remember, alpha and beta form. The alpha forms of glucose, its melting point is 419 Kelvin, is obtained by crystallization from concentrated solution of glucose at 303 Kelvin, while the beta form, its melting point is 423. Alpha, its melting point is 419 Kelvin, and it is obtained by crystallization from concentrated solution of glucose at 303 Kelvin, while the beta form, its melting point is 423, means 4 degree difference is there. Alpha is 419 melting point and it is 423 Kelvin, 4 degree difference. This is the beta form and is obtained by crystallization from hot and saturated aqueous solution. Means glucose solution you have taken, then this you will get from the hot and saturated aqueous solution of glucose at 371 Kelvin. Means alpha you got at 303 Kelvin. Correct? Alpha glucose you got or you can get at 303 Kelvin, but beta 371 Kelvin. See how much difference is there. 68 degree difference. Not say 67. Not 68. That is 68. Because first one is 303 Kelvin. This is the 71. Then 68 degree difference is there in both. Then these three properties are not discussed, or facts what I told you are not discussed, are not explained by the structure 1. Correct? You remember all these three. Then why you need a cyclic structure? Because structure 1 is not explaining all facts of glucose. That happens, but it is not, it can't be explained by the structure 1, means open structure. Correct? But by cyclic structure, that also can be these three what I told you properties which is not explained by the open structure or structure 1. Now by cyclic structure, these properties also can be explained. These facts can be explained. These three what I discussed now, this behavior could not be explained by the open chain structure, means structure 1 for glucose. It was proposed that one of the OH group may add to the CHO group and form a cyclic hemi-ester structure. Very, very important point. It was proposed that one of the OH group may add to the CHO group. 5 OH groups are there. Then one OH group may attach to the aldehyde group. Correct? That one of the OH groups, 5 are there, any one. That also will be cleared which one, but one of the OH groups may add to the CHO group and form a cyclic hemi-ester structure. Because now it is joining CHO and OH group, then it will H2O will go outside because OH group and CHO from that H, that OH plus H water, it will go outside, and O is negative, or obviously O will be negative when H will go as H plus, and when OH minus will go, then carbon will have positive because OH will go as a negative. Then that oxygen negative and carbon positive both will join. Correct? They will make a bond. It is just like a ring form. That is actually called a cyclic hemi-ester structure. It was found that glucose forms a 6-membered ring in which OH at carbon 5. This actually experimentally has been checked and verified that OH at C5 is involved in ring formation. OH of carbon 5 and CHO, that O, they are making a ring, one bond. Correct? OH from 5th carbon and O from the CHO aldehyde, they are making a bond. Okay, means that is actually making a ring. Then this actually that it has been seen actually that glucose forms a 6-membered ring in which OH at C5 is involved in a ring formation. This explains the absence of CHO group. Correct? When CHO, H has gone, O has made a bond with carbon 5th. Then now there is no CHO group, no aldehyde group. Then one point is clear. This explains the absence of CHO group and also existence of glucose in 2 forms. Okay, what are that 2 forms? That is the alpha and beta. Correct? Only from this the bond formation, this explains the absence of CHO group and also existence of glucose in 2 forms. Okay, these 2 cyclic forms exist in equilibrium with open chain structure. Means for one open chain structure will convert to this cyclic structure. From the cyclic you can get open, and from the open you will get cyclic. That is the equilibrium you will get. Then what will be the difference in alpha and beta? Then I am telling you. Okay, that also I will tell you. But first these 2 structure you understand how both are related. Open structure, open chain structure and ring structure, that you can understand. It is very easy. Both are in equilibrium. Then glucose, that is the D plus glucose, that is actually open structure. There already told you that OH from the carbon fifth, that OH and H from that carbon 1, CHO, correct? Both will go as water molecules, and a bond will be formed between the carbon 1 and carbon 5, correct? And O will come automatically in the middle. O will come in the middle. Okay. This you have to understand. Again, I am telling you how reaction. I have told you that from the OH, CHO was there, correct? Then from that CHO, that CO double bond is there. CO double bond is there, C and O. Then double bond will become single bond. Then oxygen will become negative, carbon will be positive. Correct? And here carbon number 5, OH is there. Then here that OH that will go as OH minus. Then here OH minus, then carbon will be positive at carbon 5, carbon will be positive. Then this oxygen which was negative, that will join with carbon fifth. CO double bond was there, that becomes single bond, oxygen become negative, and that carbon 1, that is positive. Then this negative oxygen, that will join with carbon 5, which is positive because OH gone as OH minus. Correct? Then now you can see carbon 1 and carbon 5th joined through O. In the middle, O is there. Then now you can see this carbon 1 and carbon 5 just now formed a ring. Now what will happen to the you can say this carbon number 1 positive charge was having, because double bond broken, that time carbon became positive. Then what happened to the hydrogen? Then that hydrogen now total hydrogen became how many? Had one OH gone. Okay, then total now out of total you can say these things 5 OH were there. Then now out of 5 OH, actually carbon number 5 OH gone, correct? Then how are remaining now? There now 3, 4, 5, you will see, then till that 5 OH is there. Carbon number 1 OH is there, correct? Carbon number 1 OH is there and 1 H is there. Carbon number 2 OH is there. Carbon number 3 also, 4 also, and 5 that OH gone. And in the end CH2 OH was there. Then now here you have to understand that at carbon number 1, how H and OH came. H was okay, carbon number 1 H was there, but now carbon number 1 which was positive charge, from where that OH came. Then here actually you can understand very easily that I told you in the beginning that it will form H2O, correct? But that H2O will not go outside, only from atom it will, H and OH will go, but finally that is in the form of H plus OH minus. H plus OH minus. Then now carbon number 1, that was the plus. Then here actually OH will come with OH from the carbon 5th, that OH is negative, that will join with carbon number 1 positive. Then H, already one H was with carbon, then that H and this OH. Then at carbon number 1, H and OH both are present. Or if you will think that okay, carbon number 1 H and OH from carbon 5th went, then it will not go out, it will be only in molecule adjustment will be there. Rearrangement will be there like that. But in a simple way, very easy way, you can understand that now ring is formed, then already one H was there, CHO, only one double bond become single bond. One H was there, and that carbon is positive, and OH gone as negative. Then now that OH minus, will join to the carbon 1, which is positive. Hence carbon 1, you will get H and OH. Then total number of OH is as it is. Only from the carbon number 5, it came to the carbon number 1. That's only. And double bond of CHO double bond was there, that become single bond. And through that oxygen only, it is because oxygen was negative, that joined with the carbon 5th, which was positive, and it form a cycle. Okay, both open structure and this cyclic structures are in equilibrium. Okay, open chain structure and cyclic structure both are in equilibrium. Then this is actually called alpha glucose. Now beta glucose also, all things are same. Again through O bond will be formed same way. But here only one thing you have to see. In beta glucose I am going to tell other form. Then here in the alpha form, OH is at the right side, at carbon number 2, not at carbon number 1, OH is at right side in alpha. In alpha glucose, alpha D-glucose, OH is at the right side. Correct? OH is at the right side. And in beta carbon, it is left side. At carbon number 1, OH is at left side. This is the only difference. Alpha and beta. Okay, you should remember, alpha means carbon number 1, OH is there, that is the right side. And in beta, OH is at left side. And other sides are hydrogen. When OH will be right side, then H will be left side. When OH will be left side, the H will be right side, opposite. Then you remember, OH is right side in alpha, and OH is in left side in beta. Correct? Then one is called alpha D glucose, alpha D plus. Both are plus only, but one is alpha, other is beta. Both are D glucose, because it is following this thing, glyceraldehyde form. In that form, OH was at the right side. Correct? Last means 5th carbon I am talking about. There is no disturbance. All things are there. Only here, that is actually both are plus only, because they follow this things, plus glyceraldehyde, that they are following plus. Means this plus means, I told you, dextrorotatory, right side rotation. Then here alpha or beta meaning you understood. both are D glucose, but only D, both are D plus. Only difference that alpha means carbon 1 has OH group at right side, and in beta OH group, carbon 1 OH group is left side. Okay, then this I have told about the formation of a cyclic structure. Then by this structure actually explains the absence of CHO group, because that CHO group O involved in making cyclic structure, and also existence of glucose in two forms. Okay, these two cyclic forms exist in equilibrium with open chain structure. Correct? Now further I am telling you the two cyclic hemiacetal form. You have seen alpha and beta, I am talking about that. The two cyclic hemiacetal form, both are alpha and beta, both are in cyclic form. Correct? The two cyclic hemiacetal, that is also called hemiacetal. The two cyclic hemiacetal forms, the two cyclic hemiacetal forms of glucose differ only in the configuration of hydroxyl group at carbon 1, called anomeric carbon. Anomeric, already you know the meaning. Okay, the aldehyde carbon before cyclization. The aldehyde carbon before cyclization, that you know, that C1 only it differs in position of OH. Then these two isomers, two types of isomer, alpha and beta you got. Such isomers, that is the alpha form and beta form, are called anomers. Question is asked. Correct? These two form, alpha form and beta form, are called anomers. The six-membered cyclic structure of glucose is called pyranose structure. Don't forget, very very important. Many question is asked based on that. Again I am telling you, the six-membered cyclic structure of glucose is called pyranose structure. Correct? Alpha or beta, whatever be, both structures are called pyranose structure. Pyranose, pyranose structure. Okay, in analogy with pyran. Pyran means what? Pyran is a cyclic organic compounds with one oxygen atom and 5 carbon atoms in the ring. That is called pyran. Because this hemiacetal structure of glucose is matching with pyran structure. Correct? Pyran is a cyclic organic compound, cyclic, with one oxygen atom and 5 carbon atoms. It is matching with glucose, alpha or beta. It is matching. There is also 6. Here is also 6. There is one oxygen, because oxygen is making link with carbon 1 and carbon 5. It is making link, and with carbon 5 below that CH2OH is there. Then including that total 6 carbons are there. That in the ring, what you are saying, 1 is oxygen and 5 is carbon. CH2OH is outside of ring. Then this is called pyranose structure. The 6-membered cyclic structure of glucose is called pyranose structure, maybe alpha, maybe beta. In analogy with pyran. Pyran is a cyclic organic compound with one oxygen atom and 5 carbon atoms in the ring. The cyclic structure of glucose is more correctly represented by Haworth structure. Haworth is the name of scientist. Haworth ORTH, Haworth structure. Pyranose structure is called Haworth structure. Question is asked. Remember, Haworth structure is pyranose structure. Then pyran structure, I told you that it is a total six-membered ring, but in that ring 5 are carbon and 1 is oxygen. Correct? Then this is matching with glucose structure. Then in glucose, this alpha D plus gluco, that structure you will write now glucopyranose. Alpha D plus glucopyranose only you have to add. Glucose you are writing, in the place of glucose you write only gluco, SE you remove, glucose, GLUCOSE, that SE you remove, and pyranose you add. It is called alpha D plus glucopyranose. Then structure is now in the ring form. I told you carbon, it is in the ring form. Carbon number 1, H and OH is there. H is down, H is upside, OH is down. H is upside, carbon number 1, H is upside, OH is down. Correct? This is a very, very important position. Carbon number 2, H is up, OH is down. Carbon number 3, OH is up and H is down. Means carbon number 2 and carbon number 3 opposite is there. Remember, carbon number 2 and carbon number 3 OH position is opposite, or also you can tell H is also opposite. Anyone you can remember. Correct? Carbon number 2 and carbon number 3 OH is opposite. Then obviously H will be also opposite. And carbon number 4, H will be up, OH will be down, like carbon number 1. Like carbon number 1, H will be up, OH will be down. And carbon number 5, I already told you that it is a out of ring. Then out of ring, CH2OH is attached with 5th carbon. With 5th carbon, CH2OH is attached. Correct? And inside H will be there. On 5th carbon, H is there. And outside CH2OH is there. All carbon atoms are balanced. Then 5 carbons are involved in the ring. And 6th carbon is outside CH2OH. That is the 6th carbon. Then now alpha I told you. Then come to the beta. All things are same. Only thing is difference is at carbon number 1. OH is up, that become reverse. OH went up and H became down. Correct? And all things are same. All things are same except at carbon number 1 it reversed. Others are same. Okay? No difference at all. This is called beta D plus glucopyranose. Now I am going to discuss a structure of fructose. A structure of fructose. Fructose also has the molecular formula, same molecular formula. What is that? C6H12O6. Same chemical formula, only a structure is different. Then fructose also has the molecular formula C6H12O6, and on the basis of the reaction it was found to contain a ketonic functional group at carbon number 2 and 6 carbons in a straight chain, as in case of glucose. Same way, already I have discussed it. This also has a open ring structure. Just like glucose. Fructose has also open ring structure. Only difference is that at carbon number 2 CO group is there. Carbon number 2, then that oxygen is attached, C double bond. Carbon oxygen double bond is there. Correct? And from the second carbon upside CH2OH is there, and carbon number from the carbon number 5th again CH2OH is attached. Means both end CH2OH is attached. With carbon number 2 CH2OH is attached upside, and carbon number 5th again CH2OH is attached. That is the down. One CH2OH is upside, other with carbon number 2, and another CH2OH is at carbon number 5th, means down. Then including this CH2OH carbon, inside it is the 4 carbon, total 6 carbon. But carbon number 2, with carbon number 2 oxygen is attached, CO group is there. That's why it is called, actually it is a ketonic group. Then this fructose means it has ketonic group, and glucose means aldehyde group. Then here again you will see the structure, correct structure of fructose in open. Here also will get ring, but I am telling first open structure. Then here carbon number 3, left side OH is there, left side. You remember, carbon number 3 OH is at left side, and all other OH are at right side. The simple way you remember. In glucose, carbon number 3 OH is attached at left side, and all OH are at right side. Correct? And it is matching fructose, its structure is matching which negative glyceraldehyde. You have seen this is the LAVO. It rotates the plane polarized light to the left. Then it is negative. Here you write glucose is matching with glyceraldehyde. Negative means LAVO. Okay. Sometimes a small l it is written for LAVO, and a small d is written for dextrose, small d. But capital D and capital L meaning configuration, that is a different. Okay, already I discussed. Then I have told you about the fructose. Then it is also D-fructose, but now capital D fructose, but it is a LAVO, negative sign is there. D negative fructose, don't forget. Now I am telling more about the their structure. That on the basis of its reaction, it was found to contain a ketonic functional group at carbon number 2 and 6 carbons in a straight chain, as in the case of glucose. Here also in glucose same way, a straight chain. And other things, it belongs to D series and is laboratory compound. It is coming under the D series, but it rotates the light towards left. That's why it is called laboratory compound. It is appropriately written as D minus in bracket minus fructose. Correct? Its open structure already I have told you. It also exists in 2 cyclic forms. Just like a glucose, fructose also exists in 2 cyclic forms, which are obtained by addition of OH at carbon 5. Here you remember, it also exists in 2 cyclic forms, which are obtained by the addition of OH at C5 to the CO group. Again here also making ring, but now oxygen group is at carbon number 2. Then again this will break, double bond will become single bond, O will be negative, carbon will be positive. And at carbon number 5, OH is there, then that OH will go out as OH minus, then that carbon will become positive. Then this negative oxygen and positive carbon will join, means carbon number 2 and carbon number 5. Through oxygen it will join. It will make a ring. Correct? O, that C and O become single bond. O is negative, carbon is positive. Then O negative will join to the 5th carbon, which is positively charged, and OH has gone from here as OH minus. This OH minus will, where it will go? Then it will go to the carbon number 2. Carbon number 2 is positive charge because double bond becomes single bond. That positive charge OH will join there. Then there, that carbon you will get H and OH. That carbon, carbon number 2. Carbon number 2, now first understand OH has joined. Oh, that carbon only CO. That carbon was only C and O. Then there, no hydrogen is there, original hydrogen. No. But that oxygen, double bond oxygen, double bond was there, oxygen, carbon oxygen double bond. Then now that became oxygen joined with this carbon number 5th. Oxygen joined with carbon number 5th and formed a ring. And that carbon, carbon number 2, OH has joined. And only with carbon number 2, CH2OH was already joined from the beginning. Correct? Carbon number 2 already CH2OH was joined. Then now you have seen that with carbon number 2, CH2OH is joined, and only with that carbon OH is joined. And that now carbon number 2 has a link with carbon number 5. And carbon number 5 is joined with again CH2OH and the end. Correct? Then first carbon is in the carbon number 2, CH2OH is joined. That CH2OH is that first carbon. And after that, in the end, from the carbon number 5th, CH2OH is joined. That CH2OH carbon is 6. Correct? Means 1 and 6 is out of a ring. 1 and 6 CH2OH is out of ring. Correct? Then here again same way here you can tell two form is there, alpha and beta. Here actually this structure match with furan structure. Correct? This structure, cyclic structure, what you got for the fructose, it is matching with furan structure. That I will tell about this structure, that this glucose also exists in two cyclic forms, which are obtained by addition of OH at C5 to the CO group. The ring thus formed is a 5-membered ring and is known as furanose. Glucose was known as a pyranose because of it was matching with pyran structure. Like that way here it is matching with furan, F-U-R-A-N, furan. That's why fructose is known as furanose with analogy to the compound furan. Furan is a 5-membered cyclic compound. Pyranose was 6-membered. 5 was carbon, 1 was ring, upside ring. Correct? Out of 6, 1 was oxygen atom. 6 was oxygen atom. 5 was carbon. But here it is a 5-membered ring. 4 is carbon, 1 is oxygen in this ring. It is called furan. In pyran also you can tell that 2 double bond is there in pyran also in opposite direction. In opposite direction means suppose oxygen is upside, then both side oxygen is have single. Correct? it is joined with single bond with carbon. Then carbon means oxygen, if you consider as a 1, then carbon number 2. Second is the carbon, third is the carbon. Fourth is the carbon, fifth is the carbon, sixth is the carbon. Then carbon number 2 and 3 is double bond in pyran. And also 2 and 3 is double bond. 4 is carbon number 4 is a single bond. It is attached with fourth and 3 is single bond, and fourth and 5 is also single bond. Only 5 and 6, that is a double bond in front of each other. In front of each other means carbon 5 and 6. Atom 5 and 6 also you can tell. Then that is a double bond. Actually carbon start with 2. Position 2 is, that is the first carbon. Oxygen is there, after that carbon is there. That is the carbon by, that is the first. First and second is double bond. Third with second and third single bond. And third and fourth is also single bond. Okay. Third and fourth is single bond. And fourth and fifth is double bond. Means both are in front of each other. And again carbon number 5th and oxygen is a single bond. This is the case of pyran. But in furan, same way, oxygen in the top, and both oxygen and carbon is joined with single bond. And that carbon means carbon number 1, through which oxygen, carbon number 1 and carbon number 4, carbon number 1 and carbon number 4, oxygen has joined with single bond. Then carbon number 1 and carbon number 2 is double bond. Correct? And 2 and 3 is a single bond. And 3 and 4 is a double bond. Again, it is coming in front of each. But it is the 5-membered ring. You remember, 5-membered ring. This is called furan. Then glucose, from this now, this cyclic structure of glucose is matching with furan. That's why it is called fructofuranose. Fructofuranose. Don't confuse. Furanose. Fructofuranose. There it was the glucopyranose. Glucopyranose. And now here it is a fructofuranose. Correct? Fructofuranose. Furanose came from the furan. OSE you have added. Furanose. And in there it was glucopyranose. Pyran was there, OSE you have added. Then here in fructose you will get alpha and beta same way. Alpha D, both fructose are in minus, don't forget, it is laboratory. Then alpha D minus fructofuranose, beta D minus fructofuranose. Okay, both only alpha and beta is changing. All things are same. Then here you will find Y alpha and beta. Then now here also you will find that here OH situation you have to see, but here means you have to see CH2OH. That things CH2OH you have to consider. Then here that in alpha CH2OH, first CH2OH is in the left, and last is means carbon number which was joined at carbon number 5th, that is the right, and which was joined at carbon number 2, that is the left, and left is there, that's why you are minus, you are telling minus. Okay, left. Right means left means always you understand OH is becoming CH2OH, that is the left, that is alpha. You remember it is different from beta. That in glucose that is a different. Here is a different. Here OH CH2OH in the left, that's why it is alpha. And here in beta, CH2OH is inside the ring, that is called beta, you remember. If outside of ring, then alpha. If inside the ring, then beta, you remember. Okay, then this I have told you these things, two form, alpha and beta. The cyclic structure of two anomers, both are anomers also, of fructose are represented by Haworth structure. This is also represented by Haworth structure. Same way what I discussed with in case of glucose, same way. Only difference is that is the 6-membered, this is the 5-membered. Then here that carbon number 2, CH2OH, and OH is there, already I told you. CH2OH is up at carbon number 2, CH2OH, and down OH is there, upside CH2OH and down OH, correct. And at next carbon, that is the carbon number 3, OH is upside, H is down. Carbon number 4, H is up, OH is down. Here again you will find opposite, carbon number 3 and carbon number 4. Carbon number 3, OH is up, correct, and carbon number 4, OH is down, opposite. Third carbon you remember, correct, third carbon you remember where is the OH. Then third carbon, OH is upside, means inside the ring, H is outside. Okay, the fourth again opposite of this, correct, OH is outside, and carbon number 5th, CH2OH is outside. Both CH2OH is outside in case of alpha D fructofuranose in Haworth structure. In Haworth structure, alpha D, that is both are outside, out of ring, okay. But this what you can tell, this CH2OH, now that carbon, first carbon, one is called first carbon, at carbon number 2 CH2OH was joined, that carbon is 1, and carbon number 5th again CH2OH is joined, that carbon is 6. Then this carbon number 2 and carbon number 5, CH2OH is there, then both are outside, okay, both are outside, you remember, and you are in parallel, you can say are in parallel, both are out in the same direction. But means carbon, this carbon number 2 and carbon number 5, you remember better, with carbon number 2 and carbon number 5, CH2OH is attached, this you remember, and both are in a parallel, okay, parallel. But here in beta D fructofuranose, beta D fructofuranose, it is a minus, both are minus, alpha or beta. Then here you will find that again here carbon number 2 and carbon number 5, CH2OH is there, then now it is opposite to the alpha. In alpha, carbon number 2 CH2O was upside. Now this CH2OH is down, in case of beta, correct. In case of beta it is down, but in alpha CH2OH was upside, and with carbon number 6 CH2O was there, it is as it is outside. That's why in case of alpha both CH2OH are outside and in parallel. Here also both are outside only, but they are opposite in direction. 6 carbon, 5th carbon attached CH2OH, that is upside, and carbon number 2, now C with carbon number 2 CH2OH is down and OH is upside, reverse of alpha fructanose structure, means alpha D fructanose structure and beta D fructanose furanose structure, both are opposite. Only at carbon number 2 all things are as it is. Only at carbon number 2 they are opposite, reverse, other things are same. Now I am stopping only here. Next class I will discuss disaccharides. Under that sucrose and maltose is there. Lactose also I will discuss. That is in the next class. Okay. Thank you.